All right, this here is our second electricity problem. This one's a little bit different from the previous one because this is a function that changes over time, so its derivative is not zero. We're using this equation, resistance, inductance, capacitance, and the energy applied. In this case, this 377T, and that cosine sort of correlates with plugging it into a regular 110, 120 volt wall, regular wall socket. Okay, so we're using this equation right here. So I'm going to quickly plug in the correct pieces. So you can see 0.25 I double prime plus 10 I prime plus this fraction times I equals. Notice we got E prime of t, so I need to take the derivative of this. So E prime of t is equal to, I'm going to multiply 110 by 377. That gives me 41970. The derivative of cosine is negative, so there's a negative out here. And then it's times sine of, and the original piece stays because that's some chain rule, 377t. So that's what's going to go over on this right side. So I get negative 41970, not cosine, sine of 377t. All right, so before I go any further here, let's point out that this can be simplified to 1,000. The easy way to do that is to say, all right, I got a decimal and move it 1, 2, 3, and then do that same move, 1, 2, 3, and you see that I get 1,000 up there, 1,000 over 1. So that's 1,000. And then there's a variety of ways to do this problem in several different areas. I tend to like to have I double prime here, not have a coefficient, because many of the ones that we do don't have a coefficient there, don't have that 0.25, and I'm less error prone if I make it more like ones I've done a bunch of. So I'm going to multiply everything by 4. That gives me I double prime plus 40 I prime plus 4,000 I equals, when I do this multiplication, I get negative 165,880 sine of 377t. And you know, maybe you can do that multiplication in your head, but I'm using a calculator to do this right here, 4 times that. Okay, so let's do my XC or my IC first. So IC, we're going to do R squared plus 40R. Come on, pen. Plus, all right, I'm going to complete the square on this 40. I divide it by 2 and I square it. That gives me, divided by 2 is 20, and then square that and I get 400. And then equals, all right, if I do negative 4,000, so move that over, plus my 400. This is going to simplify to 3,600 over here. So, what's that give me? R plus 20 squared. This one's nice in that I can actually complete the square with it. It's been designed to be able to complete the square with. Sometimes we can't, and there's various other methods. Oftentimes, like quadratic formula or something like that's going to work for us. But since I can't complete the square here, I'm going to roll with that. Equals 3,600. Come on. It's negative, because of negative there. So that gives me R plus 20 equals plus or minus 60I. That works really well, which gives me R equals negative 20 plus or minus 60I. So what's that give me for my XC or my IC? IC is e to the negative 20t, open parentheses, C1 cosine of 60t plus C2 sine of 60t. So from there, I need to do a comparison with my E prime. What do I have over here as my input? It's got a sine of 377t. There's no issues with this, so I don't need to deal with any repeated or duplicated roots. So I'm just going to do a normal undetermined coefficients work, and I'll switch to blue for that. So again, what I'm going to take is this right here. I don't need to carry the coefficient. And I don't even, and actually what I'm going to do to make sure I don't mess this up is box the line that I'm actually going to do undetermined coefficients on. I'm going to use this one again because it has that coefficient of 1 there. All right, so IP is equal to capital A cosine of 377t plus capital B times sine of 377t. I'm going to do some derivatives here. IP prime is 377a. Sine, it's negative because of the derivative, open parentheses, 377t plus 377b cosine of 377t. I got to do one more derivative line. IP double prime is equal to. All right, we've got a negative. I'm just going to write it as 377 squared. A cosine of 377t. To me, it's easier to do that than to actually square 377. I'm going to use my calculator to do this work anyway. Plus, all right, sorry, this is minus now finally, minus, again, 377 squared b sine of 377t. So now that I have these derivatives, we need to go and plug them into the equation that I circled in blue up here at the top, right there. So we'll switch colors again. Now, you got to be really careful about what gets multiplied here. I double prime has a coefficient of 1. So I'm going to write 1 times here. And then I prime, there's a prime missing right there. Maybe you noticed that earlier. Has a coefficient of 40. And then the last one, I, which is the top of this list, has a 4,000. So I'm going to multiply those out, and then I'm going to set it equal to this right-hand side right here. So in order to do that, I'm going to zoom in here. All right, so I'm going to do it in the order in which it shows up in this blue equation. So I'm going to do I double prime first, then I prime, then this. So I get negative 377 a cosine, and I'm just going to go like that. All of these have the 377s in them. That's this term times 1 minus 377 squared b sine of, that's this term. Next one, I'm going to do minus 40 times 377. That's 40 times this, times an a sine of, and then a positive 40 times 377b cosine of. And then, so I got this and this done. And now I got to multiply this line by 4,000. So I'll do that down here. So plus 4,000 a cosine of, and then plus 4,000 b sine of. And then that is equal to, take it up from the top up there, that negative 165,880 sine of. All right, so from here, I'm going to turn this into a matrix. And I'm just going to go straight into I turn it into a system of equations, but I'm just going to go straight into the matrix form of that. So I have my sine line, I have my cosine line, I have my A, I have my B, my bar, and then this. So let's start with things. Let's see colors here. I'm going to do my signs in green. So that gives me this, and this, and this, and that one. So I get a negative 165,880 over here for the right side of the sign line. All right, A coefficients. All right, I've got this one right here. So that's negative 40 times 377. I will cross that out there. And then, all right, so B coefficients. I've got this one, a minus 377 B squared sign. I've also got this 4,000 B sign. So I'm going to write the 4,000 first because it's positive, minus 377 squared. And I'm going to cross that out and that out. Now I'll switch to purple. For the cosines, I've got this, and this, and this, and then there's nothing on the right side. So I got a 0 there. I get a, all right, let's do the A's first. I get the 4,000A minus 377A. So 4,000, oops, minus 377, yep, 377 squared. There should be a squared there, shouldn't there? Yep, I'm missing that squared. That squared came from this. Maybe you saw that. All right, so I got that taken care of and that taken care of. Now I just need to have this one here. So it's a 40 times 377. All right, so from here, I'm not going to show this step on the calculator, but you just plug this into your matrix on the calculator. You can plug it in just as is. You know, you can type 40 times 377 in that A entry, and this times this in that B entry, and it'll just do that math and give you whatever that decimal is. Then we're going to go ahead and RREF, and I get A equals B equals. All right, my A in this case is 0.1296, and my B is 1.1868. And that tells me what my undetermined coefficients pieces are. So here's A, here's B. So when at this point, all I need to do is write out the full solution. So my x of t, not my x of t, my I of t, the current flowing through this thing, is equal to e to the negative, what was it up there? What did I get for my xc? E to the negative 20. So it's e to the negative 20t, open parentheses, c1 cosine of 60t plus c2 sine of 60t. Close parentheses, plus, all right, A is 0.1296, and that gets attached to, A was my cosine. So cosine of 377t plus, make that look a little bit better, the B, which is 1.1868 sine of 377t. And that is the solution to the current through that circuit given this right here. So I will zoom out so you can maybe have a picture of the whole thing in there. It's probably pretty small, but there you go. That's how we solve that problem, and hopefully you feel pretty good with that. See ya.